part A of this question, we have to explain what a zero-sum game is. So a zero-sum game is a game when the winnings of one player equal the losses of the other player for each possible combination of strategies. In part B, column X dominates column Y in a zero-sum game with two players when for each row the element in column X is less than the element in column Y. In part C, the game described in the question has no stable solution because the minimax is different from the maximum. So the maximum is 4 and the minimax is 5. Just to remind you that the maximum is the maximum of the minima for each row, and the minimax is the minimum of the maximum from each column. So in part D, to find the best strategy for Molly, you have to consider the matrix that you get when row 3 dominates row 1, and Molly should never play row 1 because the probability is 0, which means that she should play row 2 2/3 of the time, and row 3 1 minus p, where p is 2/3 of the time, so that is 1/3 of the time. And now for E, the value of the game for Molly is 14 divided by 3. And now if the game changes according to the table in the question, the graphical approach is not possible in this case because row 3 doesn't dominate row 1. And now for B, Molly can identify her best strategy using the simplex method, so that is a linear programming method.